In this question, there are two coherent slits S1 and S2 illuminated by light from a source S. The screen, the center of the screen is O. T1, T2 are straight lines joining from S1 to screen, S2 to screen, normal to its plane. C2O is D. That means S1, T1 is D. S2, T2 also D, because CO is D. S1C. S1C, this distance is capital D. Even CS2 is capital D. That means total from S1 to S2 is 2 capital D. Normally, this was not the case. S1, S2 practically was very small, millimeters of order, and the capital D was in meters of order. So this particular case, S1, S2 is larger than S1, T2, sorry, S1, T1, CO or S2, T2. The distance from CS1 is D. That means O to T1 also D. CS2D means O to T2 also D. Now, so it's a double slit experiment. Distance of the screen from the slit is half the distance between the slits. This is the distance between the slit. Half of that will be the distance of the screen. That means this is D, this will be 2D. It's given already from here. Obtain the value of D, an expression for D in terms of lambda, such that the first minimum of the interference pattern on the screen fall at a distance D from the center. First minima is falling at a distance D from the center. If this is O, distance D from O is T1 or T2. Because it's already given S1C is D, CS2 is D. So the point where first minima falls D from the center O is T1 on the upper side or T2 on the lower side. Now, condition for minima in interference pattern is path difference between light from S1 to the point, S2 to the point. Here T1 is the point because the D is distance from O to center to the first minimum. So S1 T1, S2 T1, S2 T1 is greater than S1 T1. The path difference between light from the two coherent sources to the point supposed to be equal to 2n minus 1 lambda by 2 with n value being 1, 2, 3. That's for the condition for minima or interference pattern. For first minima, n will be equal to 1. So 2 into 1, 2 minus 1, 1. So path difference should be lambda by 2 for the first minima. Now from the diagram, we can find the path difference as S2 T1 minus S1 T1 because the point where first minima is T1. So S1 T1 already we have capital D because CO is capital D. Now for finding S2 T1 path, we can take this right triangle S2 S1 T1. So the hypotenuse side is S2 T1 equal to root of altitude square, which is D plus D, 2D the whole square, plus S1 T1 D square. S1 T1 is D square. So S2 T1 will be, or S2 T1 square, hypotenuse square will be 2D whole square plus D square. So S2 T1 will be root of 4d square plus d square. 2d whole square plus d square. So root of 5d square. So root 5d. So we have got S2 T1 and S1 T1. Now the path difference will be S2 T1 minus S1 T1. Already we have a path difference in terms of wavelength. Now we have a path difference in terms of S2 T1 and S1 T1. So we can substitute left hand side and right hand side. Left hand side will be lambda by 2. Right hand side S2 T1 is root 5d. S1 T1 is d. So get d common out. So d root 5 minus 1 bracket is lambda by 2. So you can take root 5 minus 1 to the left. So d will be lambda upon 2 times of root 5 minus 1. Root of 5 minus 1 whole into 2. So that's a demanded expression for d in terms of wavelength.